Hello everybody, today we will be beginning our talk on binomial expansion. This is part 2 of what we did last time. So last time we derived how to expand a binomial raised to a certain power. So, just as a quick recap, here's an example of that. So let's say that we have 2x minus 3y raised to the third power, and I'd like to write out all the expansions without having to use FOIL if possible. So we said that the result is that this will consist of 4 terms, and I know it's 4 terms because it's always going to be one more than the exponent that's over here. So in terms of what those terms are, it's going to be consisted of 2x and then negative 3y, and then we have 2x, and then negative 3y, 2x, and then we have negative 3y, and then we also have 2x, and then also negative 3y. As one part of the binomial increases in exponent, the other one will decrease in exponent in a way such that the sum of the two exponents are always still going to be equal to whatever the exponent is at the very beginning, which in this case is 3. So that means that the first term, you have an exponent of 3 for 2x, and then that means you will have the 0 exponent for the negative 3y. Then the next one will be 2, then the exponent, next one will be 1, then the next term, the exponent will be 1, and then the exponent will be 2. And then finally for the last one, the exponent for 2x will be 0, and then the last exponent for negative 3y will be 3. Those are going to be the variable parts of each of the monomials that will add up to be this binomial. So in the end, we're going to go ahead and add up all of these together. And keep in mind that there's also a coefficient that's in front. And the coefficient actually is going to be an n choose k scenario where the numbers that you're using for n choose k will be the same as the exponents. So the first part will be 3 choose 0. And then the next part will be 3 choose 1. And then the next part will be 3 choose 2. And the next part after that is going to be 3 choose 3. Okay. Now, technically, those n choose k, we could actually use 3 choose 3 for the first one, 3 choose 2 for the second, 3 choose 3 for the 3 choose 1 for the third one, and then 3 choose 0 for the last one. It actually doesn't matter what the bottom number is when it comes to picking which one of those exponent it is, because in the end they all come out to be the same thing. So either one should be okay. Okay. So then afterwards, now we just go ahead and simplify each one, and then we just add them all up. So let me go ahead and erase this part of the board over here, okay? And then we can go ahead and write that out. So let's see, the first part, 3 choose 0, that comes out to be 1. 2x raised to the third power, that's going to be 8x cubed. Negative 3y raised to the 0 power, that is going to be equal to 1. For the second term, 3 choose 1, that comes out to be 3. Now, just for your reference sake, I'll go ahead and do this once so you can see what that looks like. That's going to be the same thing as 3 factorial divided by 1 factorial times 2 factorial. So that's what you're really just putting in the calculator if you're not sure as to what is it that you're inputting. Then the next part, the 2x raised to the second power, that will give you 4x squared. And then for the next one will be negative 3y. And again, all of these will be multiplied together. Third term, that's going to be same thing, 3 choose 2. So that is going to be same thing right here. So 3 factorial over 2 factorial, 1 factorial, which I know is equal to 3. But if you don't know that, you can go ahead and put it in the calculator. Multiply by 2x, and then multiply by 9y squared. And be very careful because when the term gets squared, the negative is going to go away. So that's why it's positive for this term, whereas the previous term is going to be negative. And finally, for the last one, that is going to be 3 choose 3, which is equal to 1 once again. Multiplied by 1 because 2x raised to the 0 power is equal to 1. And then the last one will be negative 27, negative 27y to the cube. So let me go ahead and erase that a little bit. Okay, so 9x squared and then negative 27y cubed. Okay, and again, we're just going to go ahead and add up all the terms, and that'll be our final answer. So finally put it all together. Let's see. So the first term is 8x cubed and then plus 3 multiplied by negative 12 x squared y, and then after that is going to be plus 3 times 2 times 9 times x times y squared. And I noticed there's a small little mistake, so I'll go ahead and change that a little bit. Ended up erasing everything, so I do apologize for that. Oh, and I better, oh man, I am not good at this at all whatsoever. Okay, sorry. So negative 27y cubed, that's what I had here. And this one was supposed to be 9y squared, whereas this guy is supposed to be negative 3y. So sorry for that small little technical difficulty. And finally, the last term will be minus 27y to the third. So I'll clean it up one last time so you can see. Final answer will be 8x cubed minus 36x squared y. And then we have, looks like it's going to be plus 6 times 9, which is equal to 54, multiplied by xy squared. And finally, minus 27y cubed. Okay, so that's going to be the expansion then. Now, for anything that is a lower degree for this binomial expansion, like say, to the third power, to the fourth power, you're probably better off just go ahead and using FOIL to figure things out, because it's probably a little bit faster. But a typical type of question that you might find on, like, say, the SAT 1 or SAT 2 or in any textbook would be something like the following. So for, how about, let's say this time, x cubed minus 4y raised to the 10th power, something a little bit more difficult. I'm not going to ask you to expand the entire thing, because that's going to be very tedious for the most part. But instead, a common question that you might see is the following. Here, let me go ahead and write it out. Find the term containing y to the 6th. Okay. So then that means we have to kind of utilize what we learned over here previously in order to figure that out. So the best way to do so is the following. Let's go ahead and set up the same thing as what I just did earlier. We have the first part of the binomial is going to be x cubed. We have the second part of the binomial, which is negative 4y. Each one of those will have an exponent, and I need to figure out what those are, because as soon as I do, we can figure out the rest of it. Well, since the problem says that I need to find a term that contains y to the 6th, then I know the exponent for this part, negative 4y, has to be to the 6th power. And according to our rule of what we said earlier, how the sum of the exponents that I introduced right now is going to be equal to 10, which is the exponent of the original binomial expansion, then that means that this guy right here is going to be to the 4th power. And once you get the 4 and the 6, then the rest is actually pretty easy, because this part right here is going to be 10 choose 4 or 10 choose 6. Okay, and then now we just go ahead and write out the rest, and then that's going to be our answer. So first piece, let's see, 10 choose 6, that's going to be 10 factorial over 6 factorial 4 factorial. Okay, x raised to the 12th power, because we multiply the exponents. And then we also have 4 to the 6th power, because the negative is gone since you have an even exponent. And we have y to the 6th then. So in the final form that a lot of people probably want to put this in, it'll be 10 factorial over 6 factorial 4 factorial times 4 to the 6th times x to the 12th, y to the 6th. And if you would like to use a calculator for this, that's totally fine. But usually what I do as a teacher is I just tell my students to leave it in this form, because when it comes to factorial, if you have to punch something in to a calculator that's like beyond 10 factorial, the number is too big and it's just not worth writing out. So we'll just go ahead and leave the answer in factorial form. Okay. Let's try to look at another variation of this type of problem. Let's say this time, for the same setup, I want you to find the term, okay, containing x to the 15th. Okay, so I want you to find a term that contains x to the 15th. So we'll do the same procedure. We know that you're going to have x to the 3rd raised to some power. We know you have y times negative 4, and again, I made a small little mistake, so let me erase that. You have negative y times 4 raised to some power. those two exponents right there that I'm introducing, the sum will have to be equal to 10. Now, this part is a little tricky because we have x to the 15th, which when you look at the very beginning, you might think, hey, you know what? There's really no way for me to get x to the 15th because you're raising the whole thing to the 10th power. But it turns out that you can because, remember, you have x to the third from the beginning. So the question then is, well, if we have x to the third, what power do I have to raise it to in order to get to the 15th, to get x to the 15th? Well, that's an easy multiplication part for most of us. That number would then be 5 in this case, okay? Because x to the third to the power of 5 will give us that x to the 15th. And as soon as we figure out that that's equal to 5, then that means that this part right here for negative 4y is also raised to the 5th. And then the coefficient in front, or the n choose k part in front, will then be 10 choose 5 then. So once again, we'll go ahead and write out everything. So the 10 choose 5, that's the same thing as 10 factorial over 5 factorial, 5 factorial. Then we have x to the 15th power, which is what I wanted. And also we have negative 4 raised to the 5th power. So that's going to be negative, literally 4 raised to the 5th power and y to the 5th. And putting it into its final form once again, we'll put the negative outside. We have the 4 to the 5th. Then we have 10 factorial over 5 factorial, 5 factorial. X to the 15th multiplied by y to the 5th. Okay, so as I said, I'm just going to go ahead and leave the factorial in that form. 4 to the 5th, you can find the answer, but again, when multiplied by the factorial, I think it's just going to be such a big number that it's not really worth writing it out. A small little side note that I should mention is that if a problem says something like similar to part B, find the term, okay, containing x to the 11th, then that's going to be a problem because you'll notice that if I do the same thing, we will have x to the third raised to something, and then we have negative 4y raised to something, and that something has to give me 11. 3 times something is equal to 11. Let me write that as a question mark. So 3 times question mark is equal to 11. The question mark would then be equal to 11 over 3. And that right there is impossible because your exponents, according to what we've been doing so far, they always have to be integer values. So in this case right here, if they ever ask you a question like this, just think x to the 11th is not a multiple of 3 because we have x to the third, so therefore there's going to be no solution. Okay. All right, let's look at the last type of problem, and that's going to be it. Okay. In the last scenario, I want to look at the following. Find the coefficient, okay, coefficient of the fourth term. Okay, I want to find the coefficient of the fourth term. So this variation is a little bit different than what we did in part A, part B, and part C, in the sense that they're telling us now what term they wanted to find. So that means that we need to, still figure out what the exponent is, and it might be, the method might be a little bit different. So nonetheless, let's go ahead and set it up first. We know it's, again, x to the third raised to some power, and we know that it's also negative 4y raised to some power. The question is, what are those exponents for the fourth term? Well, if you go back to my very, very original example right here, where you can see 2x minus 3y raised to the third power, this right here, that's my first term. This right here, that's my second term. This right here, that's my third term. This right here, that is my fourth term. The way it works is that there are n plus 1 number of terms where n is equal to the exponent of the binomial you're trying to expand. But more importantly, to answer what we just said earlier, if you look at the term, right, the second exponent should be 1 less than the term number. So here, for example, the third term, you can see how I have y to the second. For the second term, we have y to the first, and then for the first term, we have y to the 0, and for the fourth term, we have y to the third. So then that means that if I want to answer my question over here, find the coefficient of the third term, then I know that for the second variable, the exponent over here should then be equal to 3 because that's 1 less than 4. Once again, once we know one of the exponent, then we know the other part, which is then equal to 7, because 7 plus 3 is equal to 10. And finally, we put in the n choose k part, so it's going to be 10 choose 3 then. So finally, the answer is going to be 10 factorial over 3 factorial, 7 factorial, x to the power of 21. And then we also have negative 4 to the third power, y to the third power. So final answer, it's negative 4 to the third power times 10 factorial over 3 factorial, 7 factorial, x to the 21st, and y to the third power. And since it says I'm only looking for the coefficient, then my actual answer, and this is the part that's a little tricky, is just the numerical value, which is this over here. Okay, so you actually disregard the x to the 21 and also y to the third. All right, so that should do it. I will see you guys next time.